Hi, today we're going to talk about 5-6, the remainder and factor theorems. Let's get started. First, I want to let you know that the remainder theorem is heavily dependent on your skills with synthetic division. So let's go ahead and practice synthetic division. I'm going to have 1, 6, and 2 because I'm looking at the coefficients here and I notice that my powers are all visible. I have a power 2, power 1, and power 0. In my corner box, I'm going to put whatever x is equal to, which in this case is 4. And then I begin my process of bring the first one down and then multiply and add, multiply, and add. So 42 is what would be my remainder. And for the rest of it, remember to put your variables back on there. So x plus 10 plus 42 over x minus 4. Okay? You kind of need to recall how to do that in order to do what we're about to do next. What we're going to do here is evaluate f of 4 in this function. I really think that you already have a good idea of how to do that. Everywhere I see an x, I'm going to replace it with a 4. Fourth minus 2, I'm replacing that x with a 4 plus 5 times 4 plus 2. And I'm going to go ahead and take a minute to work. So after I plugged in the 4, I'd use PEMDAS, or order of operations, to help me decide how to work out this problem. And my answer was 622. I think we're all pretty familiar with how to evaluate that way. Now what I'm going to show you is another method called synthetic substitution. Synthetic substitution. Where I can pretty much use synthetic division to help me get this answer in a different way. You might think it's quicker, and it's pretty beneficial. So I'm going to set up my synthetic division using making sure all my powers are there. Power 4, 3. I'm missing a power 2. So I have to add a 0, power 1, and then power 0. So let's see. I'm going to have 3, negative 2, 0, 5, 2. And in this little corner box, we always put what x is equal to. Well, if I was plugging in a 4, then that pretty much means x is equal to 4. So I don't have to like change the value or anything on that one. Let's go ahead and start. 12, 10, 40, 160, 165, 660. So, if you notice one thing, with synthetic substitution, the remainder theorem is that the remainder will give me my answer. So I can evaluate by plugging in 4 and doing all the work to get the answer, or I can use synthetic substitution and get the answer much quicker. All right, let's try another one. I'm going to plug in f of 3, and I'm going to do this using synthetic substitution. So I'm going to make sure all my powers are there, 3, 2, 1, 0. And 3 is in my corner box. 3 times 3 is 9. 3 times 3 is 9. 3 times 10 is 30. And then I get 19. So this number here is my remainder. And so 19 would give me my answer. F of 3 equals 19. We're going to go ahead and skip that one. You can do it on your own if you like. But here's the next part of our notes, which is the factor theorem. The factor theorem tells me that if a binomial is a factor of a polynomial, that'll only be true if and only if my remainder is 0. So let me show you what that looks like. Sorry, that happens sometimes. Let's see, so we're going to look at x minus 5 and determine if it's a factor of this polynomial. So I have a power 3, 2, 1, 0. I'm going to set up synthetic division. So I'm going to have a 5 in my corner box. going to have a 1, negative 7, 7, 15. 1, negative 2, negative 3, negative 15. So what the factor theorem tells me, if my remainder is 0, then x minus 5 was a factor. So was x minus 5 a factor? Yes, it was, because my remainder was 0. So what I'm going to do here is go ahead and rewrite these numbers as a polynomial, which it would be x squared minus 2x minus 3. The second half of this says find the remaining factors. So in order to do that, find the remaining factors, I need to go ahead and factor this quadratic. A is 1, B is negative 2, C is negative 3, and A times C is again negative 3. What two numbers multiply to give me negative 3 but add up to negative 2? Negative 3 and 1. So because A is 1, I know I can just write my factors x minus 3 and x plus 1. So was it a factor? Yes. And what are my remaining factors? My remaining factors are here. Not forgetting that x minus 5 actually was one of the original factors as well. All right, let's look at this one. Determine whether x minus 2 is a factor, and then find the remaining factors of the polynomial. Why don't you try this one on your own? When I worked this with synthetic division, I got a 0 remainder. So that would mean to me that, yes, this is one of the factors. And I would just have to, at this point, factor out my quadratic expression. A, B, C, and AC. So what two numbers multiply to give me negative 6 but add up to negative 5? I'd have negative 6 and 1. So x minus 6 and x plus 1 would be my two factors. All right, and then we're going to try this one last one. So it's already telling me that 2x plus 1 is one of the factors, and I'm going to have to find the other remaining two factors. So let's see how we start. I'm going to start by setting up my synthetic division, power 3, 2, 1, 0. So 6, negative 25, 2, and 8. And think about what goes in my corner box. I have to make sure to set this equal to 0 and solve it. So x equals negative 1/2. And let's get started. Bring down the 6. Get negative 3. Positive 14. Negative 8. So we wanted it to be that 0 because it told us it was one of the factors. One thing that you'll have to remember when we're doing synthetic, if my coefficient here was not 1, then I need to make sure to divide all of my end factors by whatever that coefficient was before I write my polynomial. So I'm going to have 3x squared minus 14x plus 8. And I'm going to start with A, B, and C. My phone is ringing? All right, so on this one, A is 3, B is negative 14, C is 8, and A times C is equal to 24. So I have to think of two numbers that multiply to give me 24, but when I add them, I get negative 14. So if you're not sure, just break down 24. What are all the factors? There's 1 and 24, 2 and 12, there's 3 and 8, 4 and 6. But which one is going to add up to give me negative 14? It would be here, but I would do negative 2 and negative 12. So with that being said, negative 2 and negative 12, I'm going to split the middle term with negative 2x and negative 12x. And let's see, I'm going to bring the rest down. 3x squared and 8. Then I need to do grouping here. So in this red group, I'm going to have an x in common. And what's left over is 3x minus 2. And let's see, I'm going to do a brown group. In this group, I have a negative 4 in common, and what's left over is, again, 3x minus 2. So my remaining factors are x minus 4 and 3x minus 2. All right, there you go.